The process of osmoregulation occurs within the kidneys, specifically within structures called nephrons. There are thousands, if not millions, of nephrons per kidney. And while these structures are microscopic, they are critical for homeostasis, as they regulate an animal's blood volume by controlling the amount of water and ions within the blood. The process of osmoregulation begins when systemic blood in need of filtering enters the glomerulus. The capillary tuft comprising the glomerulus is fenestrated, meaning small slits exist between the endothelial cells of the capillary's walls. These slits allow particles of small molecular sizes and weights like glucose, amino acids, ions, and water to pass out of the glomerulus and into the first part of the nephron, while larger items such as blood cells are retained in the capillary. When small molecules leave the blood through the fenestrations, they enter the Bowman's capsule and collectively form a substance called filtrate. It is the job of the Bowman's capsule to collect this filtrate and send it on to the next part of the nephron, which is the proximal convoluted tubule. The proximal convoluted tubule is the major site of nutrient and ion reabsorption. Reabsorption entails the removal of molecules from the filtrate and into the extracellular fluid for uptake into a nearby blood capillary. In the proximal convoluted tubule, 100% of all glucose molecules and amino acids in the filtrate are reabsorbed back into the blood. In addition, approximately 60% of all ions are reabsorbed. In order to accomplish this, the cells of the proximal convoluted tubule contain many ion leak channels, transporters, and even energy-requiring pumps to ensure efficient reabsorption of vital nutrients. In most vertebrates, the proximal convoluted tubule is followed by the loop of Henle. The most important function of this portion of the nephron is the reabsorption of water. The longer the loop, the more water can be reabsorbed. The process of water reabsorption actually begins by the removal of sodium and chloride from the loop's filtrate and into the extracellular fluid. As the osmolality of the extracellular fluid increases, more water is pulled from the filtrate via osmosis and then is reabsorbed into a nearby blood capillary. The sodium and chloride may either follow the water and be reabsorbed into the blood, or they may be secreted back into the filtrate for removal in the urine. The fate of these ions depends upon the ion concentration in the blood and the hydration level of the animal. The final portion of the nephron is the distal convoluted tubule. For most vertebrates, this tubule represents the last chance for ion reabsorption or secretion, and thus one of the last places where osmoregulation can occur. Once filtrate leaves this portion of the nephron, its composition is mostly set and will become urine.